On July 20th, 1969, the world watched in awe as humans took their first steps on the moon. Neil Armstrong's words, "That's one small step for man, one giant leap for mankind," resonated across the globe. This momentous achievement marked a turning point in human history. It signified our ability to push beyond the confines of our planet and venture into the cosmos. The Apollo 11 mission was the culmination of years of scientific research, engineering ingenuity, and unwavering human spirit. It proved that seemingly impossible dreams could be realized with determination and innovation. More than just a lunar landing, Apollo 11 sparked a global fascination with space exploration. It ignited the imaginations of generations to come and set the stage for even bolder missions. The legacy of Apollo 11 extends far beyond that single event. It inspired countless scientists, engineers, and dreamers to reach for the stars. It led to the development of new technologies that have revolutionized our lives here on Earth. From satellite communication to medical imaging, the ripple effects of Apollo 11 are still felt today. The moon landing was not the end of our journey, but rather the beginning. It ignited a passion for exploration that continues to burn brightly. As we stand on the precipice of a new era in space exploration, we carry with us the lessons learned from Apollo 11. We are reminded that with courage, collaboration, and a thirst for discovery, humanity can achieve the extraordinary. The success of the Apollo missions ignited a desire to venture further into the cosmos. These missions were not just about landing on the moon, they were about pushing the boundaries of human potential and exploring the unknown. The triumph of Apollo 11, where humans first set foot on the lunar surface, was a monumental achievement that showcased our ability to overcome immense challenges. It was a testament to human ingenuity, determination, and the spirit of exploration. Mars, with its reddish hue and mysterious allure, became the next target in our sights. The red planet, often visible to the naked eye from Earth, has long fascinated astronomers and dreamers alike. Its surface, marked by vast canyons, towering volcanoes, and polar ice caps, presents a landscape both alien and intriguing. The possibility of ancient life, hidden beneath its dusty surface, adds to its enigmatic charm. Our celestial neighbor, promising the potential for groundbreaking discoveries, captured our collective imagination. The idea of setting foot on Mars, of exploring its valleys and plains, became a dream shared by scientists, engineers, and the general public. The allure of Mars lies not just in its physical characteristics, but in the questions it poses about the history of our solar system and the potential for life beyond Earth. The journey from the Moon to Mars, however, presented a new set of challenges. Unlike the relatively short trip to the Moon, a mission to Mars involves traversing millions of miles of space. The vast distance means that any mission to Mars requires careful planning, advanced technology, and a deep understanding of the risks involved. The challenges are not just technical, but also psychological, as astronauts must endure long periods of isolation and confinement. The distance between Earth and Mars is vastly greater than that between Earth and the Moon. While the Moon is about 240,000 miles away, Mars can be as far as 250 million miles from Earth, depending on their positions in their respective orbits. This immense distance means that communication delays can be significant, with signals taking up to 20 minutes to travel one way. This necessitates a high degree of autonomy for any Mars mission. This means longer travel times, increased exposure to radiation, and the need for more sophisticated spacecraft. The journey to Mars could take anywhere from 6 to 9 months, depending on the alignment of the planets. During this time, astronauts are exposed to cosmic radiation, which poses significant health risks. To mitigate these risks, spacecraft must be equipped with advanced shielding and life support systems capable of sustaining human life for extended periods. Technological advancements became paramount in order to conquer this new frontier. Innovations in propulsion technology, materials science, and robotics were essential to make a manned mission to Mars feasible. Engineers and scientists worked tirelessly to develop new systems and technologies that could withstand the harsh conditions of space and ensure the safety and success of the mission. We needed spacecraft capable of withstanding the rigors of deep space travel. These spacecraft had to be designed to endure the long journey, protect the crew from radiation, and provide all the necessary life support systems. This included everything from air and water recycling systems to food storage and waste management. The design and testing of these systems required meticulous attention to detail and rigorous testing. Scientists and engineers focused on developing new propulsion systems, life support technologies, and communication arrays. Propulsion systems had to be efficient and powerful enough to make the journey feasible, while life support systems needed to ensure the health and well-being of the crew. Communication arrays had to be capable of maintaining contact with Earth despite the vast distances involved. These advancements were essential to sustain human life during the long and arduous journey to Mars. The development of closed-loop life support systems, which recycle air, water, and waste, was crucial. These systems had to be reliable and efficient, capable of operating autonomously for months at a time. The health and safety of the crew depended on the flawless operation of these systems. The journey from the Moon to Mars represents not just a physical journey, but a technological one as well. Each step forward in our quest to reach Mars has been marked by significant technological breakthroughs. From the development of new propulsion systems to advancements in life support and communication technologies, each innovation has brought us closer to realizing the dream of setting foot on the Red Planet. Each mission to Mars built upon the knowledge and experience gained from previous endeavors. The data collected from earlier missions provided invaluable insights that informed the design and planning of subsequent missions. This iterative process of learning and improvement has been key to our progress in space exploration. The Viking missions in the 1970s provided our first glimpses of the Martian surface. These missions were groundbreaking, as they included the first successful landers on Mars. The Viking landers conducted experiments to search for signs of life and sent back detailed images of the Martian landscape, greatly expanding our understanding of the Red Planet. The Sojourner rover in the 1990s demonstrated the feasibility of robotic exploration. This small, six-wheeled rover was part of the Mars Pathfinder mission and was the first rover to operate on another planet. It provided valuable data on the Martian terrain and tested technologies that would be used in future missions. With each mission, we inched closer to unlocking the secrets of the Red Planet. The data and experience gained from these missions have been instrumental in planning future manned missions to Mars. Each success has built upon the last, creating a foundation of knowledge and technology that will one day enable humans to set foot on Mars. The quest to reach Mars fueled a spirit of innovation that extended beyond the realm of space exploration. The challenges of a Mars mission have driven advancements in a wide range of fields, from materials, science to computer technology. These innovations have not only made space travel more feasible, but have also had far-reaching impacts on other industries. It fostered collaboration between nations and disciplines, driving advancements in fields like materials science, computer technology, and robotics. The international nature of space exploration has brought together the best minds from around the world, fostering a spirit of cooperation and shared purpose. This collaborative approach has been essential in overcoming the many challenges of space exploration. These technological leaps had profound implications for our lives on Earth, further blurring the lines between science fiction and reality. The technologies developed for space exploration have found applications in everyday life, from medical devices to advanced materials. The quest to reach Mars has not only expanded our horizons, but has also enriched our lives in countless ways. The Artemis program, spearheaded by NASA, marks a pivotal step in our journey to Mars. This initiative is not just a mission, it's a vision for the future of space exploration. By setting our sights on the Moon first, we are laying the groundwork for the more ambitious goal of reaching Mars. This ambitious program aims to establish a sustainable presence on the Moon. The Moon will serve as a proving ground where we can test new technologies and systems in a relatively close and controlled environment. This will help us understand the challenges of living and working on another celestial body. This is not simply a repeat of the Apollo missions, but rather a strategic stepping stone to the Red Planet. The Apollo missions were about proving we could reach the Moon. Artemis is about proving we can stay there and use it as a launch pad for deeper space exploration. By utilizing the Moon as a testing ground, Artemis aims to refine the technologies and strategies needed for long-duration space travel and habitation. This includes everything from life support systems to habitat construction and even the psychological aspects of long-term isolation. A key component of the Artemis program is the Lunar Gateway. This orbiting space station will act as a command center and a staging point for missions to the lunar surface and beyond. This space station, orbiting the Moon, will serve as a hub for future missions. It will facilitate the transfer of crew and cargo and provide a platform for scientific research and technology demonstrations. The Gateway will provide a docking station for spacecraft, a platform for scientific research, and a staging point for expeditions to the lunar surface. It will also serve as a testbed for new technologies that will be crucial for Mars missions. It is a crucial link in the chain that will ultimately lead us to Mars. The experience gained from operating the Gateway will be invaluable for the design and operation of future Mars missions. The Artemis program emphasizes international collaboration and partnerships with private companies. This global effort brings together the best minds and resources from around the world, fostering innovation and ensuring the success of the mission. This collaborative approach allows for a pooling of resources, expertise, and perspectives, accelerating the pace of innovation. By working together, we can overcome the technical and logistical challenges of space exploration more effectively. The development of new technologies, such as advanced life support systems and in-situ resource utilization, is central to the Artemis program. These innovations will not only support lunar missions, but also pave the way for sustainable human presence on Mars. The lessons learned from Artemis will be invaluable as we prepare for human missions to Mars. Every experiment, every mission, and every piece of data collected will bring us one step closer to the red planet. The challenges of living and working on the Moon, such as dealing with radiation, dust, and extreme temperatures, will provide crucial insights for Martian exploration. Overcoming these challenges on the Moon will prepare us for the even harsher conditions on Mars. Artemis is not just about returning to the Moon, but about testing the technologies and strategies that will enable us to become a multiplanetary species. By mastering the challenges of lunar exploration, we are setting the stage for humanity's next giant leap, Mars. While humans have yet to set foot on Mars, robotic explorers have been diligently surveying the planet for decades. These robotic rovers have become our proxies, venturing into the unknown and sending back a wealth of information that has revolutionized our understanding of Mars. These mechanical pioneers serve as our eyes and ears on the red planet, sending back invaluable data that shapes our understanding of this alien world. They have captured stunning images, analyzed soil samples, and even detected signs of ancient water flows. From the early days of the Sojourner rover, which was the first to roam the Martian surface in 1997, to the sophisticated Curiosity and Perseverance rovers, each mission has pushed the boundaries of robotic exploration. These missions have laid the groundwork for future exploration and have provided us with a treasure trove of scientific data. The Curiosity rover, which landed in 2012, has been exploring the Gale crater, searching for signs of past life and studying the planet's climate and geology. The Perseverance rover, which arrived in 2021, is equipped with advanced tools to search for signs of ancient microbial life and collect samples for future return to Earth. The rovers are equipped with an array of scientific instruments, cameras, and tools to analyze the Martian surface and atmosphere. These instruments include spectrometers, drills, and environmental sensors, all designed to gather as much information as possible about the Martian environment. They have traversed vast distances, climbed mountains, and delved into craters, uncovering evidence of past water, organic molecules, and potential signs of ancient life. These discoveries have profound implications for our understanding of Mars's history and its potential to support life. Each new discovery fuels our curiosity and brings us closer to unraveling the mysteries of Mars. The excitement and joy of scientists back on Earth as they celebrate these findings are a testament to the importance of these missions. The development of rover technology has been nothing short of remarkable. Engineers and scientists have continuously innovated, creating more robust and capable machines with each new mission. Each generation of rovers is more sophisticated than the last, boasting enhanced mobility, scientific capabilities, and autonomy. These advancements allow the rovers to navigate the challenging Martian terrain more effectively and conduct more complex scientific experiments. These advancements allow us to explore more challenging terrain, conduct more complex experiments, and collect more detailed data. The ability to climb steep hills, traverse rocky landscapes, and collect samples from diverse locations is crucial for comprehensive exploration. The rovers are not merely tools for scientific exploration, they are also proving grounds for technologies that will be essential for future human missions. The data and experience gained from these robotic missions are invaluable for planning human exploration. They are also testing new technologies that will be critical for human survival on Mars. For instance, the Perseverance rover is testing a device that can produce oxygen from the Martian atmosphere, a technology that could be vital for future astronauts. The development of autonomous navigation systems, for instance, will be crucial for rovers and human explorers alike. These systems allow the rovers to make decisions on their own, navigate around obstacles, and find the best paths to their destinations. Similarly, the ability to extract resources from the Martian environment, such as water ice, will be essential for establishing a sustainable human presence. This capability will reduce the need to transport resources from Earth, making long-term missions more feasible. The rovers are paving the way for humanity's arrival on Mars, one discovery at a time. Each mission brings us closer to the day when humans will set foot on the red planet, building on the legacy of these incredible robotic explorers.